Last season, Arsenal won the Premier League, but with some of those players reaching their peak, we're going to have an active transfer window to make sure that we retain the title. Now, while I'm never going to be Arsenal's manager, I wanted to find out if I could build a bunch of AI agents using the Microsoft Agent Framework to create the perfect summer transfer window for Arsenal, and learn how they can orchestrate with each other to find the best targets to sign this summer. The Microsoft Agent Framework comes with 5 different patterns to help with multi-agent orchestration. By the end of this video, you'll know which one to use for which scenario. I'll walk through the 5 orchestration patterns that the Microsoft Agent Framework provides: Sequential, Concurrent, Group Chat, Handoff, and Magentic. For each one, we'll talk about what it does, when you should use it, and how you can create the orchestration workflows using C#. But before we get started, if you're into .NET, Azure, and AI engineering tutorials, don't forget to like and subscribe for more content. The Agent Framework is Microsoft's open source SDK for building AI agents. You give an agent an instruction, some tools, and it uses that in combination with a large language model to read the input, make decisions, and get things done. It's open source on GitHub, and you can create agents using C#, Python, and now even Golang. An agent decides its own steps. You give it some instructions and some tools, and the model works out what to do next. The Microsoft Agent Framework makes it possible to design, manage, and scale multi-agent workflows without having to manually handle the details of agent orchestration. So instead of relying on a single agent to manage every aspect of a task, you can combine specialized agents with their own expertise and tools to create systems that solve real-world problems in a collaborative manner. This is enabled by workflows. Workflows are a structured sequence of steps that are used by agents to complete a task. Within these workflows, we can add one or more agents alongside other components to automate complex operations. Workflows give us control over how our tasks are executed. They enable multi-agent orchestration and support features like checkpointing to save and resume workflow states. You need this because one agent can only get you so far. One agent can scout a single player, but planning a whole transfer window is a much more complex task. You need to scout targets, value them, argue the priorities for your team, and keep your entire transfer plan under your budget. There are different jobs for different agents all working together, and that's the orchestration problem that we need to solve. Regardless of which pattern you use, a typical workflow will look like this. We first start by defining our agents and describing their capabilities. We'll then select and create an orchestration pattern, and optionally add a manager agent to help with coordination if we need it. We'll configure callbacks or transforms for custom input and output handling, and then we'll start a runtime to manage execution. We'll invoke the orchestration with our task that we want our agents to complete, and we'll retrieve results in an asynchronous, non-blocking way. One of the benefits of the Microsoft Agent Framework is that all patterns share the same core interface. We can experiment with different strategies without having to rewrite our agent logic. The SDK abstracts the complexity of agent communication, coordination, and result aggregation, so we can just focus on building our workflows. So to demonstrate the 5 different orchestration patterns, I've created a very simple console application that's going to act as our transfer room for Arsenal's transfer window. This is based off 2 files. So I've got a JSON file for Arsenal's squad, which I've sourced from EA Sports FC 26. I've taken their player ratings, and I've also used FIFACM.com's ratings as well to get their predicted rating, as well as their transfer and weekly wage. I've also got a JSON file for transfer targets. Basically, these were sourced from BBC.com's gossip column to see which players have been linked with Arsenal, and I've also added a couple of wonder kids there, as well as getting their stats from EA Sports and also FIFACM. Now, I've tried to make this data as realistic as possible, but it is still demo data. If you see your favorite player on here and you think he's underpriced or underpaid, don't take it so seriously. It's just a demo, just have fun with it. There are a couple of players in here who have already signed for different clubs, particularly Morgan Rogers. I mean, seriously, how much do you think they're paying him not to play in the Champions League? Utter madness. But first, let's take a look at sequential orchestration. This means that agents are arranged in a logical pipeline where each agent processes the task one after the other. The output from one agent is used as input for the next, and this is great for workflows where each step depends on the previous agent. In the transfer room, we're going to take an example of a scouting desk. For this example, say we want to scout a particular player, and we have 3 agents that analyze the player. One for determining what type of player they are based on their stats, another who weighs that profile against their asking transfer fee and wage demand versus the budget that we have, and finally we have an agent that writes a complete scouting profile for the player with a recommendation whether we should sign him or not. So let's see how sequential orchestration works. I've got this markdown file titled The Brief, and it's essentially going to outline some objectives that I want to achieve in this transfer window. I have an aging squad, so some players are reaching 30 years old or are over 30 years old. Getting rid of some of those players might be needed to generate transfer funds and free up the wage budget. And I also have priorities for attackers and defensive options as well. I've got some following players who I consider indispensable, as well as some players that are dispensable. So to take a look at the sequential desk, first off, we've got our workflow runner, and that's essentially this scouting report pipeline. We're going to run these 3 agents within a fixed order. We're going to invoke our sequential orchestration by asking which target should I scout and provide a player's name or default value of Nico Williams. We then have our 3 agents. So our first agent is going to take those raw ratings in the JSON file and turn that into a playing profile. Then we have another agent that's going to weigh their profile against their transfer fee, wage demands, and our budget. And then finally, we're going to pass the output of that into our report writer, who's going to write a final scouting report with a verdict of whether we should sign the player or not. We'll open up a terminal, and I'm in the Football Scout project directory, so I'll type .NET run -- sequential. So which target should we scout? I'm going to use Nico Williams. This is a player that I think that Arsenal should sign. And from there, it's going to spin up the 3 agents, so our stat reader, valuer, and report writer, which are all using GPT-5 Mini. So our input of the player that we say go and scout this player, that's provided as input to our stat reader agent, who says that our target, Nico Williams, has got standout traits with elite pace and excellent dribbling. That output has been provided as input to the valuer. So £55 million would consume exactly 50% of Arsenal's remaining transfer budget, 110 million. That's based off EA Sports career mode starting transfer budget, but is affordable within the wage structure. So given he's 24 with speed, with 85 with predicted 88 value, 55 million is a fair to good price for an immediate starting caliber wide attacker. That output has been provided as input to our report writer. So Nico Williams is a high-end attacker with elite pace. And then that output has been provided as input to our verdict of whether we should sign him or not. So sign immediately. So immediate starting caliber winger with elite pace and dribbling with clear upside that fits Arsenal's remaining budget and wage space. So there's nothing too complicated about sequential orchestration. You should choose sequential orchestration in your workflow if your pipeline is made up of multiple steps that can happen in a specific order, where each step relies on the one before it. If you have tasks that can't be performed at the same time and have to build upon each other, sequential orchestration is the pattern that you should use. If you need to run tasks that run in parallel, then our next orchestration pattern, concurrent orchestration, would serve you better. And that's because concurrent orchestration lets multiple agents run in parallel on the same task. Each agent handles the task independently, and then their outputs are aggregated. If we have tasks that can be run at the same time, we can use either a fixed group of agents or bring them in dynamically to solve that task. This is particularly useful when we need different agents with different skill sets to work independently on a common goal. So taking a look at how we implement this, let's use an example of a recruitment panel. So here I'm asking which target should the panel assess, and we pass through a target of the player that we're interested in signing. we'll have 4 different agents. So we've got one for an attacking scout, one for a defense scout, a scout that determines how good the player will fit within our system, and also a value scout, so judges how valuable they are, what value for money they provide. This will go ahead, take our task and fan out so they'll all assess that player at the same time with their own unique perspective and skill set. We then have another agent which acts as a panel chair, which will merge the recommendations into one and generate a verdict for us. So this build concurrent method here allows us to pass in all our various agents, so all our different scouts, and they'll all get the same player at once. So instead of running them one by one, as we would for sequential workflows, we get 4 different agents working on the same task. I'll open up my terminal, just maximize this and run .NET run -- concurrent. And I'll use the default Bruno Guarmers. We're about to sign him, I think, around £70 million. Alright, so the defense scout has given a rating. So we've got a rating 8 out of 10. A system fit scout. So there's Bruno's a high quality athletic box-to-box centre midfielder. That said, Arsenal already have settled pivot in Declan Rice, plus several central midfielders. Given a 6 out of 10. A value scout has given a rating as well, 7 out of 10. And then the attack scout has also given a rating of 7 out of 10. And then the panel chair has aggregated those results into a monitor verdict. So you can see that all of these various different agents have concurrently worked on assessing Bruno as a target for Arsenal. And now they fanned out to do that work, and they fanned back in through the panel chair to provide us this status or verdict of monitor. So we'll monitor Bruno. So don't prioritize our primary bid right now. As of this recording, he's still a Newcastle player, but that might change. That might change very soon. We'll see. Joking aside, you can see how we use the concurrent orchestration pattern when we need different approaches to solve the same problem. So all of these different agents are working on the same task, and that's scouting Bruno to see how much of a fit he would be for Arsenal. Instead of working them one after the other, the agents have fanned out and worked on the same task at the same time. The results from each agent have then been combined to make a final answer. Now let's take a look at group chat orchestration, which essentially models a collaborative conversation. Multiple AI agents can participate in a conversation alongside humans to work on tasks such as debates or collaborative problem solving. A central chat manager will control the flow and decide which agents respond next in the conversation, and when to request inputs from a human. Group chats can support a variety of different conversation types, from free-flowing iteration conversation types to formal workflows with defined roles and approval steps. This is great for the human-in-the-loop setups, where humans have to approve an idea or a proposal that's been made by an agent. So a good scenario for this is which player should be the priority in this transfer window. I've got a couple of agents here, so this agent will back the highest rated target. This agent will back the player who addresses the biggest squad need. And I'm building this in a round-robin group chat manager. So this essentially will allow the agents to take turns and then cap them at 4 rounds so the discussion doesn't go on forever. Now you can pick a smarter manager for this, which essentially picks the next speaker based on what's been said in the conversation. But if I go ahead and open up a terminal now and run .NET run -- group chat, this will go ahead and, as reigning Premier League champions, which single target should Arsenal prioritize in this window? I'm going to choose that as my default, press enter. And through the power of video editing, we can see that these two agents have had a conversation amongst themselves and chosen which player that they think that we should sign. So the best available is Julian Alvarez. So if I look at the transfer targets JSON file, I can see Julian Alvarez is there, with a rating of 87 and a predicted rating of 89. So I'll come back into the terminal, just open that up again. And I've got a con, so the pick was Bruno. So Bruno gives Arsenal control. and then the agents rebut the other agents with their own arguments. Another squad need, so it picked Alvaro Caracas. I hope I'm saying that right, probably not. Saying that he plugs Alfinet's spot. And then you can see they're having a conversation, so they're providing rebuttals to each other's case, and then they pick the best player, so they end up on Julian Alvarez. So essentially, group chat is when you want agents to work collaboratively together and want them to talk it out. If you need a strict order, it's better to use Sequential, but if you need more of a free-flowing conversation and you need them to discuss and pick alternatives and reason on their arguments, group chat is a good orchestration pattern to follow. Now let's talk about the handoff orchestration pattern, where we let agents transfer control to one another based on the task that they're trying to accomplish. This could also be a request from a human user. Essentially, the agent hands off the conversation to an agent with the right skill set, ensuring that the best suited agent is handling each part of each task. This pattern is great when we have tasks that need specialized knowledge or tools, but the order of agents that are needed to solve the task isn't known in advance, or if the requirements are changing or emerging dynamically during processing. So this is how we would implement it in our transfer desk application. I have an agent here that acts as a triage agent, so it will take our question and essentially route it to the right specialist agent that it thinks that needs to answer the question. I have 4 agents here, so one for goalkeeping, defense, midfield, and attack. Those are all positions in football, if you don't know what football is. And when I define the workflow, I've got this method with hands off, and I'm calling it twice. So the first time we call it, we're essentially allowing the triage agent to route questions to the specialist agents. And then when we call it again, we're essentially allowing those specialist agents to route the message back to the triage agent, so that produces an answer. So let me open up a terminal, and I'm going to run .NET run -- handoff. And I'm going to ask the default question for which goalkeeper on the shortlist is the best value for money. So I've got all my agents. They're all using GPT-5 Mini. Try to keep this as low cost as possible. But you can see my triage agent has been initialized along with goalkeeping, defense, midfield, and attack. So hopefully we should see the triage agent route to the goalkeeping specialist. And there we go. So the best goalkeeper is Mike Penders from Strasbourg. Runners-up Martin van der Voort and Guillaume Restis. So essentially the fee, 12 million, wage £20,000 a week. That's not bad money to be on. And then cost per development point. So essentially, our triage agent has taken our question, which goalkeeper on the shortlist is best value for money, and routed it to the goalkeeping specialist, which is then routed that question back to the triage agent so we can get our response. Finally, let's take a look at Magentic orchestration. Magentic orchestration is a flexible general-purpose multi-agent pattern designed for open-end tasks that require dynamic collaboration. This pattern is based on the research from Microsoft Research, which they called Magentic 1. Essentially, a Magentic manager coordinates a team of specialized agents and decides who should act next based on the context as it evolves, the capability of the agents, and how the task is progressing. So let's illustrate this with an example. Imagine Arsenal's manager working alongside a scout and a financial analyst to coordinate the transfer window. In the Magentic orchestration pattern, the manager will use a reasoning model, such as 5-4, to build the plan, judge progress towards the plan, pick the next speaker, and decide when the task is completed. These are all emitted as JSON ledgers, so we need a reasoning model to do this. The scout and the financial analysts are just workers who do repeatable tasks, so suggest players, maybe some basic arithmetic, just really basic tasks, so we can use cheaper models for those agents. Between every agent turn, the manager runs. It essentially reads the transcript of the progress that has been made and decides 3 things. Is the task done? Has progress stalled? And who speaks next? And a part of this is because the manager keeps of two ledgers. The task ledger, this is a built up front and includes facts that it has plus a step-by-step plan. And then a progress ledger, which keeps track of progress being made towards completing the plan. Each reply from the worker is appended to a shared transcript, and the manager adds it into the next progress ledger update. When our scout produces a short list of players and the analyst confirms whether they're affordable or not, this counts as progress. If an agent repeats itself, this counts as a stall, and this triggers a reset where the manager agent will rebuild the task ledger and restart the inner loop. Each round, the progress ledger determines if the request has been fully satisfied. If it has, then the manager will synthesize the final answer from the transcript. So this is how we would implement it in our application. We have a brief that is wide open. So essentially, find both the players to sell and also the players to sign to fill our squad's biggest gaps in our transfer window. We have two worker agents. So we have one agent that recommends the targets to fill those squad gaps, as well as another agent to make sure that spending and wage budget is being kept within the limit. For that, we're using fast models. So we're using GPT 5.1 mini. And then we're using a reasoning model for our manager agent. So essentially, the manager agent is going to coordinate Arsenal's transfer window, and we're going to delegate tasks to our scouts and our analysts to make sure that we find the right players to sign and sell, and to make sure that we're doing it all in budget. So I'll open up a new terminal, and we're going to write .NET run --Magentic. So we can see our window planner and our scout agents and analyst agents have been instantiated. Notice that window planner is using a reasoning model for this. So we're going to be consuming a lot of tokens, and this will take a lot of time. So I'll just press enter and I'll let this cook and we'll come back to it. Okay, so through the power of video editing, we can see that the plan has been passed to the scout, who's drawn up a list of players to sell and come up with some targets to fill some key gaps in our squad, so wing back and also attacking players. Arda Güler, Estavo, Jorel Hato, that's unlikely. Malo Gusto, that's also extremely unlikely as well, but it's come up with those targets. It's, again, fake data. Have fun with it. That's passed it to the analyst, and the analyst has then looked at the current players and thought, okay, from the sale proceeds of selling all of these players, we can raise £83 million and free up just over £500,000 a week for our wages. And it's come up with some basic calculation for our transfer budget check. And then it's come up with a recommendation. So proceed with 2 signings, a wing back at £50 million and an attacker at £40 million, assuming roughly £90,000 a week each in wages, and it fits both limits. So it's come up with a final verdict. The signing fees of £90 million plus the available £193 million. This is an acceptable plan. So it's gone ahead and said, okay, after this first iteration of the plan, we can proceed to looking at more targets. And then it's gone deeper into those targets. So it's talked about Jorel Hato and also Bradley Barcola here. So we've gone through a lot of patterns, and you're probably thinking, which one should we use? Here's a very simple cheat sheet that I use to determine which orchestration pattern I need for which multi-agent situation. If agents need to execute after one another in a defined order, we'd use the sequential pattern. Agents that execute tasks in parallel, so we'll have an agent that will fan out to different agents and then fan back in, that's when we would use the concurrent pattern. If agents need to transfer control to each other based on the context of the task, this is where we'd use the handoff orchestration pattern. If agents need to collaborate in a shared conversational style manner, we'd use the group chat orchestration pattern. And then finally, if we have a manager agent that dynamically coordinates specialized agents using a ledger, this is the Magentic pattern. All 5 of these support human in the loop, so you can actually use these patterns and pause for a person to prove something before an agent runs a task. Now, I don't think I'm getting that Arsenal job anytime soon. But if you want to build this yourself, the full write-up's available on my blog, and the code is on my GitHub. Both are linked in the video description below. Feel free to use your own Foundry project and have a play with it. Use the club that you support instead of Arsenal, or use it to help you in EAFC career mode. Regardless of who you support, hopefully this helped you understand the different multi-agent orchestration patterns available in the Microsoft Agent Framework. So if you like this video, give it a like and subscribe for more. Any questions, pop them in the comment section below. Until next time, happy coding.